All right, so looking at the second part of the notes here, we have the fundamental theorem of algebra. First thing we need to talk about, though, is the rational root theorem. So what this says is there are possible zeros that we can find by using factors of the constant term, so the last term, the one without the x, divided by the factors of the leading coefficient. So that's what this says right here. So over here it says that these are possible zeros of the function, so what we have to do is test them. We know how to see if a zero actually works, like if a number is a zero of a function. Remember, we divide and see if there's a zero remainder. So let's go ahead and show you what we're doing here. So looking at the first problem here, we have factors of the constant term. So the constant term we're looking at is 12. So we need to think about all the possible factors of 12. So we're listing all possible rational zeros of the given function. That's all we're doing in this problem. So what we have a factor of 12. So 12 times 1. So I'm going to list them out here in order. We have 6 and 2, 4 and 3, so I'll have these out there. So 12, 6, 4, 3, 2, 1 are factors of 12. Okay, and what we're going to do is we're going to divide all of these by the leading coefficient, so factors of the leading coefficient. It's nice that we only have one this time, so all we have to do is put all of these over 1, which we know really doesn't do anything, but it's going to be helpful in the next problem here. So we have them all over 1, and we have to make sure that we're talking about both the positive and the negative versions of every number. So once we have these listed out, put plus minus on all of them. So right now we have 12 different possible zeros of the function. So we have 6 numbers here, 6 factors of 12, but we also have the negative versions. So you can write these not over 1 if you want when you're listing them out. Once you get used to it, you'll be fine. I don't need the 1 on the bottom. So now let's take a look at the next one. So factors of 6. So factors of 6, we need 6 and 1 and 3 and 2. But this is how we're going to do it. We're going to go 6, 3, 2, and 1. So we know those are both positive and negative. Okay, you can separate these with commas if you want. I mean, I'll be able to tell that they're individual fractions. So we need to divide by factors of 2. So now there are 2 and 1, so let's do the 1s first. Now we'll do the 2s. So divided by 2. Now we can go ahead and list the next set. So we know 6 over 2 is going to be 3. This is 3 halves. This is going to be 1. Okay, so we can simplify these. So that's what those break down into, and we have 1/2 here. So all of these divided by 1, we know we're gonna have 6 over 1. So 6 over 1. I'm just going to keep adding to the list down here. Then we would have 3 over 1, which we already have 3 here, so we don't need to write it again. And then we would have 2 over 1, so 2. And we would have a 1 over 1, which would just be this one, so we don't have to write those. So these are all the possible zeros. So again, we have 12 of them. All right. So we kind of talked about the fundamental theorem of algebra before. So we talked about the degree of the polynomial telling us how many zeros there are. And it doesn't tell you how many real ones there are, it just tells you how many total. So that can include complex zeros. So what you're going to do is you're going to find the possible zeros using the rational root theorem, the thing that we just did up here in example 1. We're going to list those out, and then we're going to test them to see if we can find which one works. So let's list out our possible solutions here. So we have leading coefficient factor 1. So that's going on the bottom, so that's good. And then 20. So factors of 20, we need to list all those out. So we have positive negative 20 and then positive negative 1. We're going to have what else? 10 and 2. And 4 and 5. So we have, again, 12 possible numbers here. So we need to test these out now. Now you can graph these on the calculator and see if we can identify a zero on the graph. Sometimes it's going to be hard, other times it's going to be easy. So if you were to graph this equation, this is kind of an easy one. You're going to have 3 answers here that are real solutions. But let's go ahead and test it. So the thing I always do is I start off with 1 or negative 1. So we can go ahead and let's start with negative 1. And we're going to do synthetic division. You could do long division if you want. So we got lucky here. So zero remainder says that negative 1 is a 0, so I know that it's going to cross at negative 1. So now it's our job to find the other ones. So we could find them whether they are real or complex by solving the quadratic, factoring the quadratic, or using quadratic formula, completing the square, any one of those methods. We would be able to find answers whether they're complex or real. So we know this factors out to be x minus 5x minus 4. So we have intercepts at 5 and 4, along with our negative 1 that we found up here. So we have a 4 and a 5, and later on we'll learn how to graph based on some other key information in the function. So we can list out our zeros down here, negative 1, 4, and 5. And if you were to graph it, it's going to look something like this. Not entirely sure where this dips down to, but it looks like a typical quadratic, or not a quadratic, a cubic function. So that's it for the notes here. So it's the same process over and over again. It can get kind of tedious, but when we don't have a calculator and we don't know what the zeros are and we need to find complex answers, this is very beneficial. So go ahead and try those and let me know if you have any questions.